Hi, I'm Leon van der Heever and welcome to Motorcycle Engine Modeling in Solidworks. In this course, we will look at modeling various motorcycle engine components with the intent of achieving a final assembly the same as we see in this picture. The goal of our project is to practice various modeling techniques, better understand the commands we use and why we do things in a certain way. We will do some basic equations, make use of configurations, and finish up with some bottom-up assembly design. We will start off at an easy pace with the intent of speeding things along a little to give you practice at improving your modeling efficiency. And this project series is geared at intermediate users of SolidWorks, and it is accepted that you have already worked through the 2014 Essentials training by Gabriel Corbett found here at lynda.com, and some additional practice after will also help. Now with that, let's get on with improving our modeling skills in SolidWorks. If you are a premium member of the lynda.com library, you have access to the exercise files used throughout this course. These files can be found on the Exercise Files tab on the main course page. The lesson files are divided by chapter, containing files for the relevant topics that we'll be covering. We also have an Assembly Components folder, which we'll use in Chapter 3, and then a Completed Assembly folder for my completed design, which you can use for your reference. I've also included for you a My Templates folder, which you can map to via SolidWorks options and file locations. Simply add the path to the location and you should have access to them. You don't have to use them. Feel free to use your own, or even the default templates will suffice. But note that I am working in a metric units system in this series. Since I do provide completed models and assemblies during the series, the lessons files would be of benefit for completion of the assembly and a number of the modeling videos. Now with that, let's get to it and I'll see you in the next video. Before attempting to follow along with this modeling series, if you've not already done so, I would recommend watching the SolidWorks 2014 Essentials training series presented by Gabriel Corbett found here at lynda.com. It will greatly assist you in keeping up with me during our modeling process, since I will not be explaining every detail about how to use certain tools or tasks that are considered to be basic and already covered during the Essentials course. Now, as a refresher to what you would have learned during the SolidWorks Essentials series, and since during the modeling process I will be referring to different dialogues, windows and tabs within the user interface of SolidWorks, let's quickly review those user interface terms I will often be referring to during the series so you can more easily follow along. At the top of the screen we have the menu bar, which has a number of frequently used menu command icons. If you hover over the SolidWorks logo at the top left corner of the screen, the menu bar will expand to the right, showing us the relevant menus with their pull downs. When you move your mouse away, the expanded menu will again collapse. I prefer to keep this expanded so my familiarity with the available menus continuously improve and I can save a bit of time when I need to activate a command from them. The expanding and collapsing of the menu can be toggled with this Keep Visible icon. Just below the menu we have the Command Manager ribbon where we find most of the common commands for easy access. From the default available tabs we will mainly be using the Features and Sketch tab. So remember where they are so you can get to them speedily. Below the command bar on the left of our screen and in the first tab of this window we have the Feature Manager where all the features we create are listed. The second tab is the Property Manager tab, which we use to make command property adjustments of sketch lines and feature commands. In the center of our screen where we do our modeling, we have the graphics area. At the top of the graphics area, we have the heads-up view toolbar, and of particular interest to us is the display styles flyout and the hide show items flyout, since we will be using them frequently as well. To the right of the graphics area, we have the task pane, which is collapsed by default and will fold out if you click on one of the task pane tabs. Note that here too, you again have a keep visible icon to toggle the pane's visibility. As discussed in the exercise file video, you can easily access the exercise files from the design library location found here. Now take a few minutes to familiarize yourself with these user interface terminologies so you know where to find them instantly as I refer to them during the modeling process. In this video, we will briefly look at some of the main workflow tools I use during my modeling process, which assist us in being more efficient in accessing certain commands and how to customize these tools so we can tweak them to suit our modeling style. Now, Solidworks has a user-friendly interface, and the developers strive to bring the required modeling commands, figuratively speaking, to our fingertips for speedy access. The first useful tool I mostly use is mouse gestures. This tool can be activated by clicking the right mouse button in the graphics view area and moving the mouse slightly in any direction. Once activated, we are presented with a wheel populated with common commands relevant to the edit mode I'm in. The commands and location of the commands on the wheel can be customized with our preferred commands and their location. A shortcut key you will want to remember is the S key. When pressing the S key on your keyboard, an in-context toolbar will be presented at the current position of your mouse pointer anywhere on the screen. The usefulness of this should be self-evident from an ease of access consideration. And this toolbar is again populated with commands relevant to the current modeling environment state, and too can be customized. Let's look at the customization options of these tools. On the menu bar, the last icon to the right has a drop-down menu where we can access the Customize command. When selected, we are presented with the Customize window. We have a number of tabs at the top, and we'll briefly look at a few of them. Select the Shortcut Bars tab. Note that we have a different context toolbar for parts, assemblies, drawings, and sketches. To add a command, select the relevant category from the toolbar drop-down. Select the command icon from the button section and drag and drop it onto the context toolbar. To remove it, simply drag it back to the button section. Note you can resize these context toolbars as well. Select the Commands tab. From the Categories window, select the Standard category. From the buttons icon, drag the redo icon and place it beside the undo icon on the menu bar. I will also remove the select icon and print icon since I can access them from other menus or toolbars. Looking at the mouse gesture tab, make sure 8 gestures is selected so we have space for additional commands. Selecting the Show Only Commands box will list the currently assigned commands on the gesture wheel. To assign a command, find it via the search field or by category. Then select the relevant drop-down field corresponding to the command and column you want, and select the position for the command on the gesture wheel. Click OK to lock in our changes. If you have forgotten where a specific command is, we have a fantastic command search tool at our disposal, which instantly finds available commands for us. At the right-hand side of our menu bar, we have a search box. Select the drop-down arrow and select commands. Let's search for near. Here we are instantly presented with a relevant command or commands, which we can run from this location. Drag to our command bar or ask Solidworks to show us its easiest access location. The right mouse button is always your friend, so use it to see what the available commands are relevant to what you are doing at that time. An important habit that needs to be cultivated when using Solidworks is to, when selecting a feature icon in the Feature Manager, an edge or face or sketch entity, learn to pause for a second. Because as you have just seen, we will always be presented with a context toolbar with commands Solidworks thinks may be useful to us within this specific environment. Yet another efficiency tool in our arsenal. Have a play with all these tools, customize them, and practice accessing them for a few minutes before continuing, and I'll see you in the next video. You will hear me talking about design intent from time to time, so I thought I'd briefly explain what it means. Considering the design intent of our model is a vital part of our modeling strategy when using a parametric software like Solidworks. Since in short, design intent is understanding how our model will behave if we make dimensional changes to it. The better you understand what changes could be requested after your model is complete, the better you can capture these design intents up front, which will save you a ton of time down the track. To illustrate this, I have prepared a simple example. We have a base feature, a boss, and a boss hole. The scenario is that in our design, it has been communicated to us that the final position or placement of the boss is not yet confirmed. I should thus ensure that if the boss position is changed, any affected features behave as expected, which in our case would be the boss hole. Design intent is captured in how we have applied sketch relations, dimensions, and or equations to our sketch or in our features. To illustrate, if we move the boss, we can see that the boss hole is not behaving as would be expected since it is left behind, and hence our design intent is incorrect. I'll do a Ctrl-Z to undo. Let's suppress the boss hole feature and unsuppress the cut extrude to feature, so we can see how properly capturing our intent would look. Now let's move the boss again. This time we see that the hole moves with the boss, and we have now properly captured the design intent. Practice understanding and establishing the design intent of your models, irrespective of how simple the model may be, so it becomes second nature to your modeling process. It does take practice and will take a bit of time to plan up front, but the results are well worth it. I will demonstrate some of this approach during the design of the flywheel part, and we may use the concept wherever we deem necessary during the conceptual design of our engine's internals. Now that we are on the same page regarding the user interface terminologies, some of my common workflow tools, and what design intent is, let's get started on the modeling of our motorcycle engine internals. We will be starting with the bottom end of our engine, and in this video we'll sketch out the necessary contours for the extrusions to block out our design. Now first create a new part using the part template from the My Template tab. Save and name the file to a location of your choice. I will name my file as 01_01_ flywheel sketch. Saving up front is a good practice and will allow us to simply do a keyboard Ctrl-S to save as frequently as we deem necessary. My preferred method of starting a sketch on a plane is to left-click on the relevant plane icon within the Feature Manager and then select the Sketch command from the Context toolbar. Feel free to use other methods covered in the Essentials course if you prefer. Now let's start a new sketch on the front plane. I'm starting on the front plane since this is the orientation I want my front view to be when doing a drawing of this part. Since this is our first feature, the graphic view will automatically rotate normal to our screen. Subsequent features will not rotate normal to our screen, and we will need to use the normal to command when needed. We will always use our origin, the two red arrows found at the center of our graphics view, as an anchor point in some way or another. This is a good practice and will make fully defining or constraining our sketches easier. Select the circle command from the mouse gesture wheel and sketch a circle with its center point constrained onto the origin. When sketching in Solidworks, we do not concern ourselves initially with the exact size of our geometry, since we will capture our design intent after the required profile is complete, with either relations or dimensions. With the circle in place, let's sketch a vertical center line with its start point on the origin, which we will use to establish both symmetry and the height for our next profile. With this in place, let's sketch the next profile. Follow my lead, and again, don't be concerned about exact sizing. Right mouse click in the graphics view and select the center point arc command, and at the top point of the center line, sketch an arc similar to this. Next, sketch the two lines joining the arc and the circle. Next, add a tangent relation to the circle and left vertical line. Simply select the circle, then Ctrl-select the line, and from the Context toolbar, select the tangent relation option. Do the same for the right-hand line as well. To select the two lines, I could instead left-click and drag my mouse from bottom right to top left, making sure I'm touching the circle and line, which is a more efficient way at times. Note that I don't move my mouse after the selection, so I can make use of the Context toolbar instead of having to go to the Properties tab to make these selections. It is far more efficient. Now do the arc points as well in the same way. I'll do the left side first and then the right. Select the 3 vertical lines, dragging from right to left again. Since we have 2 solid lines with a center line in the center of the 2, our context toolbar will now also have a symmetrical relation. Select it to make the 3 lines symmetrical. Sketch a center line horizontal between the 2 solid vertical lines. Right-click on the horizontal line so we can use the Select Midpoint command. Then Control-select the vertical line and select the Make Midpoint relation. We do this so these lines intersect exactly at their centers. We will be using the horizontal line later as a reference. Grab the Center Point Arc command again and sketch an arc as follows, making sure the start and end points are 180 degrees perpendicular to the origin. And with this arc in place, join the arc points to the circle with a line on each side to close the profile. We have completed the necessary profiles, and in the next video we will add the necessary dimensions. Now that we have our completed profile and the necessary relations are captured, we will add the necessary dimensions. Let's say that the design intent is that the center circle dimension will be our driving dimension, to which the other profile dimensions within the sketch will be related. To easily capture this, we will use equations for our dimensions. And this will allow us to later change the circle dimension, and all other dimensions will update automatically, keeping the scale of the other profiles or contours in scale to the circle's size. With the dimension tool selected, first add a dimension to the circle, and in the modified dialog that pops up, set the value to 100 millimeters. Add a dimension to the top arc, and from the keyboard select the equals key, which activates equation entry mode. Now we can select the circle's dimension from the graphics view, and using the asterisk key, multiply by 0.3. Enter and enter again. As easy as that, we can create equations for our dimensions. Now note that the red symbol now presents itself on our dimension, and this tells us there is an equation attached to this dimension. We will use percentages to keep our equations simple, and next add a dimension to the vertical center line, and in the same way, let's multiply that by 0.7. Next dimension the bottom arc, again referencing the circle's dimension, and multiply by 1.2. Our first sketch is complete and we have captured its intended design intent. Everything is looking good. Go ahead and complete the sketch from the confirmation corner, which is found on the top right of our graphics view, and let's save our work. Use the icon on the menu bar or simply Ctrl S on your keyboard. In the next video, we'll extrude the created profiles. Continue to use the file you created in the previous video, or feel free to use the lessons file. What we have just done is to create a single sketch with multiple contours. With the sketch selected in the Feature Manager, I'll activate the Extrude Boss Base command from the Features tab on the command bar to illustrate this better. Since the sketch has multiple contours, Solidworks automatically activates the Selected Contours selection box for us within the Boss Extrude properties. Now, if I hover my mouse over the sketch in the graphics view, we can clearly see that we have a top, center, and bottom contour. The reason we created these multiple contours within a single sketch is so we can use the same sketch on multiple feature commands and can speed up our modeling process. Use this technique as often as it permits within your design intent, but be careful not to try and cram the entire design into one or only a few sketches, since this could be more of a hindrance when needing to make changes down the line. A good modeler will be flexible and combine the multiple strategies SolidWorks offers us. Select the circle contour. If you do have multiple selections in these property selection boxes, you can right-click an entry and delete it, or right-click and clear all selections. Make sure that you only have the circle contour selected. We will be extruding in 2 directions with different extrude depths in this feature. For that reason, set direction 1's depth to 1 millimeter. Activate the direction 2's options by selecting this box, and set the second direction's depth to 40 millimeters. enter, and enter again to complete the command. We now have our first boss extrude in the feature manager. Clicking on the plus icon to the left of the extruded feature icon, expand the feature and again select sketch 1 so we can reuse it for our next feature as well. Do another extrude boss base and this time select both the top and bottom arc contours in the graphics view. We will extrude both contours in the same feature since their extrusion depths will be identical. Note that you do not have to hold the Control key when using Properties multiple selection boxes. Simply click on what you want to include. This time we will only be extruding in one direction, so we only need to set direction 1's properties. First, reverse the extrude direction by clicking on this icon with the 2 arrows. For our design intent, we want the depth of these contours to be the same depth as direction 2 of the circle extrude. Furthermore, if the extrude depth had to be changed, we want to ensure that this extrusion's depth will automatically update to the same depth. To achieve this, let's select the Up to Surface End Condition from the End Condition drop-down box. With the Up to Surface End Condition selected, the properties have now changed and SolidWorks is now asking us to select a plane or face. In the graphics view, position your mouse cursor over the cylindrical face of the circle extruded, right mouse click and activate the Select Other command from the right mouse options. Using this tool gives us the ability to select faces located behind other faces easily without having to rotate our graphics view, which is very handy. From the pop-up dialog, select the face or alternatively, select the face directly in the graphics view. Complete the extrude command by clicking on one of the green OK icons. Note that if I did not move my mouse, the cursor feedback indicates that I can do a right click of the mouse to complete the command as well. Again, very efficient. Control S to save your work and I'll see you in the next video. In the first video of this chapter, we used equations to capture the design intent of the sketch. We can visualize this using the Instant 3D capabilities of SolidWorks. The Instant 3D toggle command can be found on the Features command bar. Click on the first feature in either the Feature Manager or directly in the Graphics view. This will show the selected feature's dimensions. Blue dimensions are measurements entered into the feature's properties. In this case, our extruded depth. Black dimensions are what we have created at sketch level. Notice the little blue orb on the circle's dimension. I can click and drag this to adjust the dimension size in real time. Note that because of the equation constraints, as we increase the size of this dimension, the other sketch entities adjust accordingly and the profile of our flywheel looks as intended. However, notice that the 40mm extrusion depth has not scaled accordingly and has remained at 40mm. Thus, we have not captured the model's design intent fully as yet. Let's rectify this so you can see how to go about it. Do a Ctrl-Z to undo. In the Feature Manager, select the first Boss Extrude feature icon so the context toolbar will be presented. From the toolbar, select the Edit Feature icon in the left corner of the dialog. Select the D1 entry box. On your keyboard, select the equals key to activate an equation entry. In the graphics view, you will note the sketch dimensions are now visible. Select the circle dimension, which is 100mm, and multiply this by 0.01. Enter once to solve the equation. Do the same for D2 and multiply by 0.4. Enter and enter again. Let's see how our model behaves now when we adjust the 100mm dimension using Instant 3D. As we now drag the blue orb, we can see that the entire model scales as it should, including the extrusion depths, and our design intent is now fully captured for this stage of our design. With some upfront consideration and planning, you can build solid models in this way. Use Instant 3D to constantly test your design as you build and constrain. Now, we do not have enough time in this course to address every aspect of our design intent in this way, but I trust from what I have shown you, you can see how powerful this can be and how important the consideration of design intent is in our modeling strategy. We will now use the revolved boss base command to revolve the front shaft of our flywheel. The reason for using this tool instead of the extrude boss base is so we can capture our required profile from a single sketch and extrude. Start a new sketch on the right plane using the spacebar key. To bring up the in-context view orientations dialog, we have easy access to the normal to icon, which rotates the graphics view normal to our screen. Note the shortcut key is Ctrl 8 if you prefer to use that instead. Select the icon for a normal to orientation. Follow my lead as I sketch the required profile. Select the line tool. Starting on the midpoint of the front edge of the underlying geometry, sketch a vertical line, then a horizontal. Add a couple of steps similar to this. Add another horizontal line, then a vertical line down till we are perpendicular with the origin, which is denoted for us by the blue inference line, and then back to our start point. Note that the reason I started on the front edge of the existing extrude and not on the origin is so the front shaft will maintain its length relevant to that face if the underlying extrusion depth had to change. If we use the origin instead, it would simply be fixed by that and give us undesired results. Escape to cancel the active command. Make the first steps vertical and horizontal lines equal to each other. So we only need to apply one dimension. Select the Smart Dimension tool, set the right vertical line to 43 millimeters, the top horizontal line to 64 millimeters, step 1 to 6 millimeters, step 2 to 12 millimeters, and this horizontal line to 54 millimeters. From the Features tab, select the Revolved Boss Base command. Note the axis of revolution box is pre-selected in the command's properties, since we need to specify an axis. Whenever I am adjusting feature properties, I prefer to change my graphics view to the default trimetric view, so I can properly see the result of my extrusion for additional adjustments if needed. We will select the bottom horizontal line in the graphics view as our axis of revolution. Complete the command. On the front face of the newly created extrusion, we will create another extrusion. With the face selected in the graphics view, from the context toolbar, select the sketch icon. With the face still selected, select the Convert Entities command, which automatically creates a circle from the underlying geometry. Now, if the underlying geometry changes, so will the sketch. Do an extrude. Make the length 32 millimeters with a draft of 8 degrees and complete the command. Note I activated the draft dialog by selecting this draft icon. Let's do the back shaft while we are at it. On the back face of our flywheel, start a new sketch and sketch a circle with its center point vertical to the origin. Create a vertical relation from the center point to the origin so the circle is constrained in that position. Make the circle equal to the top arc. Dimension the circle 60 millimeters from the origin. Extrude the circle 50 millimeters. And your model should now look like this. We'll leave it at that, and I'll see you in the next video. In this video, we will do a number of cut extrudes to our model. Let's start by changing the view orientation to a back view. On the face of the back shaft, let's create a new sketch for our first cut. With the face still selected, select the keyboard shortcut S to bring up our context toolbar and select the Offset Entities command. In the Property Manager, enter an offset of 9 millimeters, and just below that select the reverse direction option so the sketch is created to the inside of the selected face. Go ahead and complete the offset command. If we are going to use a specific view frequently during our design, we can create our own saved views for repetitive use. For now, we will set up 2 such views. Select the spacebar to bring up the orientation window. Let's keep this dialog visible for now by selecting the Keep Visible icon, since we want to add multiple views. Change the graphic view to be similar to mine. In the orientation window, the second icon at the top left is the New View icon. Select it and name the view Back Angled and select OK. Again, rotate the view similar to mine and name this view Front Angled and select OK. You will now have both these newly created views in the orientation window for easy access. Select the Keep Visible icon to turn it off. Select the spacebar and select the Back Angled view. This is so we can see the result of our cut for necessary adjustments. To cut the hole, select the Extruded Cut command and set the depth to 25 millimeters and complete the command. Again, change the orientation to a back view. Select the inside bottom face of our first cut and start a new sketch. Again, use the Offset Entities command using an offset of 10 millimeters and reverse the direction and complete the command. Select the spacebar and select the Front Angled view to view our model from our saved orientation. Select the Extruded Cut command, and this time we will use an up to surface end condition up to this face. We do this so the cut will always go through all geometry up to this face, irrespective of how our model changes down the track. If I did not move my mouse when selecting the face, note the feedback on my mouse cursor. It is telling me that if I do a right mouse click, I can complete the command. This is another efficiency tool for us. I'm going to go ahead and do that, and we'll use this often during our modeling. So if you wonder how I completed a command so quickly at times, it's probably because I used this to my advantage. Again, change the orientation to a back view. Start a new sketch on this face. Select the inner cut's edge and offset entities again with an offset of 5 millimeters. And no need to reverse direction this time. Complete the command, spacebar, and select the front angled view we created, since we will need to select the same face as in the previous cut feature. Select the Extrude Cut command. The end condition should again be an up to surface end condition, and we will select the same face as before. Again, using this end condition for the same reasons as before as well. Go ahead and complete the command. Next, we will turn our attention to the front shaft. Select the front face of the front shaft and start a new sketch. Select the Offset Entities command. Use an offset of 7 millimeters and reverse the direction. Complete the Offset command. Select the Extruded Cut command and set a blind depth of 30 millimeters. Complete the command. We will wrap it up with that, and I'll see you in the next video where we'll complete the remaining cuts. We will continue with a couple more cuts to the back of our flywheel. We will do another revolve feature, only this time we will use the revolved cut command. Let's start a new sketch on the right plane. Rotate the view normal to. Follow along with me and sketch the following profile from the bottom vertex of the underlying geometry. Draw a vertical line up, a horizontal line to the left, an angled line slightly down like this, a vertical line down and coincident with this bottom edge, and close the profile back to the vertex. We will use this profile in the revolve cut command, but let's first fully define the sketch. Since fully defining our sketch is a best practice, and we will use dimensions to do this. Make the top horizontal line 12 millimeters. The left vertical line 21 millimeters, the right vertical line 26 millimeters, and add an angled dimension to the inside of these two lines of 107 degrees. Our profile is now fully defined, and we can tell this by the fact that all the lines are black in color. Next, a horizontal center line is needed, which will be used as an axis of revolution in the revolved cut command. With the view still normal to the right view, select the bottom edge of the back shaft so we can convert it into our existing sketch and saving us from having to sketch new geometry with the line tool. To do this, with the bottom edge of the back shaft selected, select the Convert Entities command and then change the solid line to a center line by selecting the converted line, and from the context toolbar, select the Construction and Geometry toggle icon. Next, select the Revolved Cut command. Set the end condition to be mid-plane so the cut will be symmetrical, and set the angle to 140 degrees. Now go ahead and complete the command. Before making our second cut, we need to make the first sketch of our part visible so we can reference it in our next sketch. In the Feature Manager, expand the Boss Extrude 1 feature, click on the sketch icon and select the glasses icon from the context toolbar, which shows or hides the sketch. Note we can now see the sketch in the graphics view. Change the orientation to a back view and start another sketch on this back face. Select the 3-point arc command and use the endpoints of the underlying horizontal line to constrain the arc ends. Get the arc to look something like this and click to complete the arc. Escape to exit the command. Now Control select the arc and the edge and add a concentric relation between the back shaft outer edge and the arc. We will use the Convert Entities again to create sketch entities from the underlying geometry. Activate the Convert Entities command. Select the center circle, the left edge, the right edge, and right-click to complete the command. Let's sketch a horizontal line between these 2 points to split the circle down the middle. Now we will use the Trim Entities command to trim off what we don't need. With the command selected, simply drag across the geometry you no longer need. Follow my lead, and you should end up with a closed profile like this. Select the Extruded Cut command. Set the end condition to up to vertex to allow us to use a vertex to extrude up to. Rotate the graphics view like this and select the vertex over here. Using this point, the cut depth will always be relevant to the underlying vertex position, which is exactly what we want in this instance. Complete the command, save your work, and I'll see you in the next video. Next, we want to add some shape.